So with regard to the implementation, I was able to create mock ERC20 tokens to be able to interact with some testing functionality on the same. So I looked up at the repo and also some medium post by Opyn, and also was able to just get through. So very quickly, let me just try run this. So the first thing I need to do is to deploy the mock contracts, the mock ERC20 contracts, and also I created a mock oracle and the mock controller. Since those are the mainly just borrowing from the implementation. So let's select the Solidity version compiler. So let me compile mock web. Specifying the initial supply at 10,000 at the moment. So I'm using MetaMask injected Web3. So that's a success. Let's also deploy mock scale trade ETH. So it's auto compiled. Let's also specify the initial supply to be 10,000. So mock USDC also the same. Specifying the initial supply. So the initial supply is going to be raised to 10 to the power of 18. Since it has the ERC20 token has a specified borrowing from ERC20 opens up in the decimal number of decimals is 18. So then I'll go to I'll head over and so this is a mock controller I just created. I borrowed some functions uh, from the Opyn from the protocol. So the new index is the square rooted eth price. Then the mark price is the index is the eth squared price. Then the mark price is the square rooted eth price. Then transaction period, the nominal is mark price for funding. So these are just some functions I borrowed from their repo, just to get to see on how from the documentation what they're doing. So these functions exist in the protocol: get index, get normalized mark, specifying some period for trading period, funding rate, and also there's so for the funding rate and the historical funding rates. I've not really gotten a clear implementation of the same. So I just created a custom mock to enable me be able to work with some tests. So it is auto compiled. Then let's deploy that. Then also let's compile um, the mock oracle, where we'll be creating. We're able to we set as price pool and specify set the price pool. So with this get trap, this is what will be able to fetch the period, the pool price from our implementation here. Yeah. So this is what we are going to use to get the eth what do you call it, the different token combination, the prices, specifying the base price and the quote price, which the base price is in our case, for example, if you are fetching the USDC or ETH to USDC, the base price is the base token is the USDC. Then the quote price, the quote token in this case uh, so from ETH to USDC, then the base price is ETH, the base token, then the quote token is USDC. So let's compile the most square rooted ETH oracle. No, it's the oracle. Yeah, so that being a success, we can now go ahead and the reason why I'm deploying the oracle and the controller initially before the price feed consumer is because the constructor have specified that we'll need to before when deploying the price feed consumer we need to specify the controller, in this case our protocol, the Opyn protocol, and the oracle that we'll be using. So our oracle here is our mock oracle at this moment. Then the protocol are later on in production we can when dealing with mainnet we will be able to supply specify the open addresses as the oracle. So let's deploy the consumer compilation. So with this, you can see we need the protocol address and the oracle address, which we can pick from our so the protocol address. Yeah, let's copy that address and paste it over there. Then also let's copy the oracle address. Yeah. So with that, you can see for the mock quest, this is just a custom made C20 token with the ownership functionality also. We can get the decimals, which is 18, as expected, the name, mock quest, the symbol, initial supply, is it in way, raised to power 18. So it is 10,000 raised to power 18. Then also for our controller, you see for the controller, we have from the controller borrowing from Opyn protocol, we have transaction period, total mark prices. We have uh, the denormalized mark price for a specific period. Yeah. So let's try this out. So you can set the denormalized mark price to, let's say, one for the first period. In the mock control, I just use them as integers. So for testing purposes. So let's set the denormalized mark price. So let me confirm this first. So it's not a payment, it's not a payable function, but you have to pay the gas fees. So the mark price here in our case from the Opyn protocol is a square rooted eighth price. Then the index for our case from Opyn protocol is a eighth squared price. So let's set that for our first period. Says the normalized mark price for funding for the first period. So just specifying integer values for our testing purposes. So let's set the transaction period at this moment. Yeah, so that's a success. So these are ownership function, not at the moment. You can't test at the moment. So from this, the getter methods we can fetch the denominator as mark price, which in our case this is the square rooted eighth or SQH or STTH, I guess. So you see the price is one as we had set it there. Then also you can get the index price. The index price in our case is the get index is our eight squared price. So also one. Uh, so we can get the index price by duration. We specified the above. This is just total mark prices or index prices. These are just integer values I used for custom testing on the controller. So, having interacted with the controller and perform the various functions, then we can also let's go ahead and try out the oracle. So you can set the pool price. The pool price in this case we need to let me see this. So coming to our price feed consumer using the controller functions that we've interacted with previously. Let me check if there's any email here. Not urgent. So we can get the current funding rate that we added from our controller. Also get the ETH2 price, which is the index price. Should be one as added the other time. Can also get the mark price, the square rooted ETH price or SQH. So from this, now we need to set the pool. This now we need to set the pool price from from our from the oracle. Yeah. So let's set the pool price from the oracle. So setting the price, let's pick this address. The pool price here is from the oracle address, and let's specify to 50. It's taking a bit of time. It's taking a bit of time to respond. Let me perform it again. It was a bit. So I've set the pool price to 250. So from the mock oracle. So coming to the price feed consumer, let's try get the OSQH price using our oracle. Specify check period true. So these are functions that are existing from the Opyn protocol. You can see here we have a value of 250 that we've set from the oracle, and we are fetching from the price feed consumer. Then at the same time, let's fetch let's get so Uniswap pool at it get Uniswap pool ETH price. So we'll specify the pool, which is our oracle. Then the base is our first initial token that we the combination. The base and the code are combination tokens. From the base, in this case, we want to specify the price of the mock ETH, mock WETH against mock USDC. So let's talk about the addresses. So first we'll have the oracle, which we had set its price pool. Then let's get the mock WETH. Want to specify the get the value of mock WETH against USDC. Mock USDC, yeah. Period, the first trading period. Then let's specify the check period. So these are functions that are existing from the Opyn protocol. Yeah. So it's 250 since we had set it. The price is 250. So if we specify a different value, it will also be able to do that. You can get the address of the oracle and also the address of our protocol, which we need to interact with from the consumer. So the major functions here are getting the index price, the funding rate, and also historical data, historical funding rates also. So at this moment, we've not set that from the controller. So the contract I specified using was Open Zeppelin on enable contract. So it can you can transfer the ownership to a different address. Yeah, so that's pretty much it. And thank you.